So we're going to be looking at quadratic formula today, but we're going to throw in imaginary solutions to our quadratic equations. So remember that quadratic formula, when we get ready to start working with that, we want to make sure that the equation is in the form ax squared plus bx plus c is equal to 0. So it's really important the formula is equal to 0 before you begin plugging in. So to identify the following, you want to make sure that a is always the coefficient of x squared, b is the coefficient for x, and c is the constant before substituting those values into the formula. So sometimes you can be given an equation that's not in that standard form, right? They may not have ax squared first, they might have bx first and then ax in the middle. So just make sure that you're aware of where they lie and that you're plugging their correct values in. So the formula is x is equal to the opposite of b, so be careful it's not negative, it's the opposite sign, plus or minus, so we have two solutions, the square root of b squared minus 4ac, all of that divided by a. And remember the opposite of b over 2a, that formula is your formula for the axis of symmetry for a quadratic, so that's where this relates to the quadratic graph. And then the plus or minus square root of b squared minus 4ac is your distance to your x-intercepts from your axis of symmetry. So it's not just kind of a random arbitrary formula. This is actually related to the graph of our quadratic function. So for the first example, we have 2x squared plus 5x plus 4. I don't have to move anything around. This is already in standard form. So a is going to be equal to 2. B in this equation is 5. And c is equal to 4. So again, we want to make sure that we've memorized quadratic formula. If you haven't, I'm going to write it up here in the corner for you, but you really need to be working on memorizing that formula. So we're going to start to substitute. So x equals the opposite of b, so negative 5 plus or minus the square root, b squared, so 5 squared minus 4 times 2 times 4, all divided by 2a, which is 2 times 2. So again, we just take and plug in for a, b, and c, and then we start the simplification process. So negative 5 plus or minus the square root of 25 minus 32 divided by 4. And then we're going to keep simplifying under the radical, but at this point we should start to see that we're going to end up with a negative 7 under the radical. 25 minus 32 is negative 7. So we don't want the negative under the radical. We're going to rewrite that using our imaginary number. 7 is prime, so I don't need to simplify that. And then divide by 4. And again, we want to check and make sure that we don't have any fractions that are going to need to be simplified. In this case, the 5 and the 1 and the 4 don't simplify. And again, this is a 1 right here when we're talking about that number. So we have two solutions, just like when we have quadratic equations and we take the square root, we have to remember the plus and minus. So the two solutions for this quadratic would be 5 plus I radical 7 divided by 4 and negative 5 minus I radical 7 over 4. And those are your two possible solutions to that quadratic equation. So our second example, x squared minus 9x plus 22. So again, we're going to look at a, b, and c. So a is equal to 1, b is equal to negative 9, c is equal to 22. So the opposite of b is going to be positive 9 plus or minus the square root of b squared, negative 9 squared minus 4 times 1 times 22 divided by 2 times 1. And then we're going to start to simplify. And again, we really only have to simplify under the radical. That's where the most work is going to be. So this is going to be 81 minus 88 over 2. And then x is equal to 9 plus or minus the square root of, somehow we ended up with -7 again, over 2. So 9 plus or minus I radical 7 over 2. So if you needed to, if that wasn't always a nice prime number under the radical, remember that's where we do our factor tree and we find pairs and we move those numbers out from under the radical, and if it doesn't have a partner, it stays. If you're not real sure about that and comfortable with that process, then you can go back and look at our complex number videos and practice that again. So our final two answers here, 9 plus or not plus or minus, just plus I radical 7 over 2 and 9 minus I radical 7 over 2. So solving a quadratic equation using quadratic formula is going to be just like it was before. We've just added imaginary roots here, which means we do have to take and write things as imaginary or complex numbers.